Hello everyone. So in this video we are going to discuss about a very important topic which is intervals. So in this video we are going to see a basic introduction to intervals and we will also see what are overlapping intervals. Now this is a very important topic for the coding interview. There are questions asked on the concept of overlapping intervals. So let's move ahead and see what are intervals and what are overlapping intervals. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So first we will see a basic introduction to an interval. So usually an interval is actually a range which is represented by two numbers, something like 5, 8, 6, 10. So an interval is a range where two numbers are involved. Now that two numbers are termed as start and end. So here 5 will be our start and 8 will be our end. So these two numbers are basically start and end of the interval, which actually represent a range. Now usually when we talk about interval, they are correlated with time. Now when it is related with time, this start and end can be any unit of time. It can be milliseconds, seconds, minutes. So here let's see the time interval of few tasks. Let's say task A has a time interval of 1, 3, B has time interval of 4, 5, C has time interval of 8, 10, D has time interval of 9, 11. So if we take a time axis like this, now here it could be seconds, milliseconds, nanoseconds. It can be anything. So let's say if we want to plot this task on this time axis and we take it as seconds. So it suggests that task A has start time of 1 and it has end time of 3. So if we plot task A on this time axis, it would look something like this. That A task starts from 1 and ends at 3. So it means if we take it in the form of seconds, task A takes 2 seconds to complete. From 1 to 3. If we plot B, it starts with 4 and ends on 5. So it takes 1 second. If we plot C, so the start is 8 and end is 10, so it takes 2 seconds to complete. And if we plot D, so it starts at 9 and ends at 11, so it also takes 2 seconds. So usually these time intervals represent a range, let's say for a task or for a process. And mostly the coding interview problems are given with these intervals. So here we saw that an interval has two numbers, start and end. Now let's see how we can represent this interval in form of a code. So the interval representation looks something like this, that there is a class interval. Now this is a custom class which we will create, which has two properties, start and end. So this start will represent the starting point of the interval and end will represent the ending point of the interval. So any interval takes only two numbers, start and end. And if we want to create an interval, we have provided this constructor which takes in a start and end and initialize a particular interval with these numbers. So this is how we actually represent an interval class. So now let's move ahead and see the concept of overlapping intervals. So what are overlapping intervals? So let's say if we have interval something like 1, 5 and another interval as 2, 6. So if we plot these intervals, it looks something like this. This is 1, this is 5 and let's say 2 is here. And let's say this is 6. So here if you see, this is the first interval with 1, 5 and this is the second interval with 2, 6. So now if you closely look, they are actually overlapping in this region from interval 2 to 5. So this actually suggests that these two intervals are actually overlapping with each other in this region 2, 5. So for an overlapping intervals, we actually require two intervals at minimum. Let's say if we denote it by A and B. So there will be some relationship between these two intervals. So the first relationship would be that A and B do not overlap. So it means A starts and ends here, and B starts and ends here. So here if we take an example, let's say 1, 3 and 4, 5. So this is one interval and this is another interval, but they don't overlap. If we have interval something like 1, 3 and 3, 4, then that will overlap because the end time of first interval is equal to start time of another interval. But here there is a gap between these two, so they don't overlap. The another thing would be A and B overlap, but B ends after A. So it would look something like this, that A starts here and ends here, and B starts here and ends here. So here B is ending after A, and this is our overlapping interval. So if we take an example, let's say 1, 4 and 3, 6. So here you can see these two intervals actually represent this condition, that A interval starts from 1 and ends at 4, and B starts at 3. So it means this is 1, this is 4, this is 3 and this is 6. Here B is ending after A, so we can visualize these two intervals like this. The third would be A completely overlaps B. So it would look something like this, that A is actually overlapping B completely. So if we take an example, it could be like 1, 6 for A and B could be 2, 4. So here 1, 6, 2 and 4. So it says that A is completely overlapping B. So this could be one such case. So the fourth case is A and B overlap. A ends after B. So this is pretty much same as this, but here it looks something like this. Here B was ending after A, but here A ends after B. So these two are pretty much same, only the names of the intervals have changed. B completely overlaps A. So this is pretty much same as A completely overlaps B. So it would look something like this. Here A was completely overlapping B, and now here B is completely overlapping A. So here we just need to change the order of A and B. So if this was A and this was B, so here A would be 2, 4 and B would be 1, 6. Rest everything remains the same. And the sixth case is B and A do not overlap. So this is pretty much same as A and B do not overlap. So it looks something like this. So friends, these are the 6 cases where we can demonstrate the overlapping intervals. So for a situation where these overlapping intervals come, we at least need minimum of 2 intervals. And there could be many intervals like A, B, C, D which can overlap with each other, but we actually require minimum of 2. So friends, in this video we covered what are intervals and what are overlapping intervals. So now in this video we will look into a problem of merge intervals. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So if you look at the problem, you are given with a list of intervals. You need to merge all the overlapping intervals and return a list of non-overlapping intervals. So let's see it via an example. Let's say we are given with a list of intervals like 2, 6, 1, 3, 8, 10, and this intervals can be in any random order. So we need to merge only those intervals which are overlapping to each other, and at the end we have to return a list of all the non-overlapping intervals. So the output would be 1, 6 and 8, 10. Now how this output came, we'll see in a diagram. So let's say we have this time axis and we have this intervals 2, 6, 1, 3 and 8, 10. We will plot these intervals on this time axis. So first we will take 2, 6. So the start is at 2 and end is at 6. So this interval takes 4 units of time. Now let's say if time axis is in seconds. So this will take 4 seconds. If we plot 1, 3, it would look something like this. 1 is the start and 3 is the end. And after that we will plot 8, 10. So it looks like this. So this is 2 seconds interval and this is also 2 seconds interval. So here if you see, this 1, 3 and 2, 6 are overlapping to each other. So this is the area where they are overlapping. So it means we have to merge all the overlapping intervals. So if we merge these two intervals together, we will get a bigger interval whose start will be 1 and end will be 6. So here, as these two are overlapping intervals, when we will merge these two, you can simply take this first interval and put it on the top of the second interval, and that will be our merged interval. So it looks like this. The start will remain the same because this interval came first, and the end will actually depend that which interval has the maximum capture duration. So here in this case, the first interval is completed at 3rd second and the second interval is completing at the 6th second. So we will take the max of 3 and 6 and it merges to 1, 6. So this is the merged interval because these two intervals are overlapping to each other. But here if you see 8, 10, as we have only 3 inputs, 8, 10 is not overlapping with any of these intervals, and we have to return a list of non-overlapping intervals. So 8, 10 will remain as it is like this. So therefore our answer is 1, 6 and 8, 10. If this 8, 10 would have been 6, 10 or 5, 10, then our answer would have been one complete merged interval of 1, 10. So let's move ahead and see how we can solve such problems. So for the overlapping interval, in our previous video, we saw the different use cases that when two intervals are overlapped with each other, what happens. So one such condition is A and B do not overlap. So it looks something like this, that there is a gap between these two intervals, so we can't merge them. Now if A and B overlap, but B ends after A, so it would look something like this. Now here one thing we are assuming is A will always come before B. So this diagram will make sense that B ends after A, and if A and B overlap, it would look something like this. A completely overlaps B, so it would look something like this. But still A is coming before B. B completely overlaps A in a case that both have same start time. So B is completely overlapping A, but A should come either before B or it can start at the same time. So therefore we are taking this assumption and we will come to know later why it's important. So this is one such case where B will completely overlap A, but as A should either start at the same time as B or before B, this would be one such use case. Now we will see all these cases and why they are important. So with the first case, when A and B overlaps and B ends after A, so this is the case. So when we will merge these two intervals A and B, and let's say result we denote it by C. Now as we are merging these two intervals A and B, here you can see the range of C, which is start and end, would be A start and B end. So here you can think of any two intervals, but one thing is sure, both of the intervals either will start at the same time or one of the interval would be coming first. So whichever interval is coming first, its start will become C start, and the value of C end will depend on the maximum expansion of any of this interval. So here you can see as B ends after A, B's end value will become C's end, and after merge it will look something like this. So let's say if A starts from 1 and ends at 3 and B starts from 2 and ends at 5. So here you can see this is the overlapping part. So when we will merge these two intervals, let's say we put A on the top of B, so it will become something like it starts from 1 like this and ends at 5. So this is the merging. We'll see another use case. Let's say A completely overlaps B. So in this case, if we merge these two intervals, let's say we put A on top of B, so it would look something like this, that C start becomes A start because this is the start of the interval, and as A completely overlaps B, C's end will become A's end like this. So this is one such use case. If we look at the third use case, where A start is actually equal to B start and B ends after A. So in this case, if we merge both these intervals, it would look something like this, that if we put A on top of B, the C start will be either A dot start or B dot start. It will be same, but the end will be B's end because this is the start and this would be the maximum value till both the interval goes. So in all these three use cases, one thing to keep in mind is we are assuming A will either start before B or at the same time of B. So C start will be equal to A start. This is sure. and C end, there will be a condition that we will take max of A and B end, and whichever is the maximum value, that will be assigned to C's end. So in this case here you can see A end is 3 and B end is 5. So C end becomes 5. Here you can see A completely overlaps B. So A end is greater than B's end. So therefore C end becomes A end. And similarly here, as B is completely overlapping A, so B end is having a greater value than A ends. So whichever is the maximum, that gets assigned to C end, and that will be our merged interval. Now one thing we discussed that A should start before B or at the same time. But if we look into the problem, we are given the intervals in random order. Let's say 10, 19, 3, 4, 1, 2, and let's say 2, 3. Now we have to merge all overlapping intervals. So one thing we need to keep in mind is we have to first sort all these intervals based on their start time. Once we get the start time, this condition will come into picture that one of the interval is starting before the other. And once we sort it based on the start time, all the intervals start time will be in ascending order. So we can directly compare one with the other and see if they are overlapping with each other or not. So in order to solve this problem, the first thing we need to do is we need to sort the intervals based on the start time. So this condition will come into picture that A dot start will be less than or equal to B dot start. So here A dot start in this case is less than B dot start. In this case also it is less than B dot start. But in this case A dot start is equal to B dot start. So this condition is important. So when we will sort these intervals, the merging becomes easier. Here if you see, let's say if you want to merge these two elements, we know that A dot start is before or equal to B dot start. So C dot start will directly becomes A dot start because A is coming before B. But C dot end, which we discussed here, its value will be depend on whichever interval is going to greater time span. So it would be max of A dot end and B dot end. So here in this case A dot end was smaller than B dot end, so C became B dot end. In this case if we merge these two elements, then B dot end was lesser than A dot end. So when we merge it became A dot end. And similarly here B dot end is greater than A dot end. So therefore on merging C end becomes B dot end because we have to take the maximum of A dot end and B dot end. So these two conditions are very important. And once we do the merging of let's say two intervals, we can keep proceeding ahead with all the overlapping intervals and we can check which are overlapping intervals and we can merge them. So friend, let's see the demonstration of this algorithm step by step. So we have this merge method which actually merge the overlapping intervals, and we are given with a list of interval, and our task is to merge the overlapping intervals and return a list of all non-overlapping intervals. Because once we merge all the overlapping intervals, they all become non-overlapping. So first we will call the merge method. We pass in the list of intervals. So it would look something like this. That this is the list of interval 7, 9, 2, 6, 1, 3, and they are in random order. So the first thing we have to check that whether interval size, whether it is less than 2 or not. So if it is less than 2, it means list has either 0 elements or 1 element. It means there is only one interval or 0 interval. So we don't have to merge anything, we have to simply return the same list back. So this is one edge case. So currently intervals.size is 3, therefore it is not less than 2. Now in order to compare whether all these intervals are overlapping to each other, what we need to do is we have to sort all these intervals based on their start time so that we can come to know that whether there is any overlap or not. So the list has a sort method which takes in a comparator, and comparator has a comparing int method which actually returns a comparator. Now in this method, this is a static method. So in this method we are simply telling that take each interval and sort it based on the start time. So this comparing int method will take this intervals list, will sort it based on the start time. So the intervals will become something like this: 1, 3, 2, 6, 7, 9. So start time So 1 is less than 2, 2 is less than 7. So it has sorted based on the start time. Moving ahead. Now as we need to return a list of all non-overlapping intervals, we will create a result list like this. So currently it's empty. Now as we have sorted the intervals based on the start time, we will compare the adjacent intervals so that we can check whether they are overlapping or not. So in order to compare all these intervals, the first thing we do is we simply take the first interval as it is. So this is the time axis and the first interval is 1, 3. So if we plot it here, it looks something like this. Now our task is to compare this 1, 3 with 2, 6 and check whether anything is overlapping or not. So for that we will create two variables start and end. We will see its significance later. So to the start variable we will assign first.start because we are starting with this interval. So start becomes 1 because first.start is 1. And to end variable we will assign first.end. So first.end is 3. So we are simply taking this two intervals start and end as 1, 3. And now as we have to compare it with other intervals, we will take all these intervals in a for loop and we will start with 1 because 0 is already taken. So this is 0, this is 1 and this is second index. So we will start I from 1. So it would look something like this, that we are now picking up 2, 6 and I is less than intervals dot size. 1 is less than 3. So this condition comes out to be true. Now you can think start and end represents first, and in the for loop currently we are on 2, 6. So this becomes our current interval and this can be treated as previous intervals. So from this list we will get that interval by calling intervals.get. We'll pass the value as 1. So we will get 2, 6. So this will be assigned to the current like this. And if we plot it here, you can see 2, 6. Now our task is to simply check whether 2, 6 is actually overlapping with any of the previous intervals or not. So we will check whether current.start is less than equal to the end. So we are not doing first.end because there could be many intervals before this current interval, and start and end will represent just the previous interval which are being merged or non-overlapping. We will see its importance later. So we are simply comparing current.start whether it is less than equal to end. So here you can see value of end is 3, current.start is 2. So this is the start for current. It is less than end. So it means that there are overlapping intervals. And if you see via this example, 1, 3 is actually overlapping with 2, 6. So this condition comes out to be true, which means we have to merge these two intervals now. So once you merge these two intervals, let's say the result interval is C. So we also saw that C.start was equal to A.start, which always remains A.start because A is either starting before B or at the same time as B. So here our start will remain 1 only, it won't get changed. But C.end will become the max of A.end and B.end. So here this is the condition for that we are simply taking the maximum value of current.end, which is the current interval, and value of end, which is the value of its previous intervals, which is 3. So if we do 3, 6 max, we get 6. So here you can see our start will remain the same, but end will change to 6 now because we are merging these two overlapping intervals. So end will become 6. Moving ahead. So here you can see one reason of picking start and end in a different variable is, as we have merged these two intervals, start became 1 and end became 6, and there could be a possibility that once we move ahead in the array, there could be another intervals like this. So here in this case, all this interval will get merged together. So therefore, only the end will get expand till the intervals are overlapping and start will remain the same. So therefore, we have created these two variables which are doing those things. these two variables are keeping the state of the previous intervals which are merged or which are yet to merge. So now we'll increment I will become 2. 2 is less than 3. So this condition comes out to be true. Now this is our current interval 7, 9. So when we will do intervals dot get 2, we'll get 7, 9 as our current interval, like this. So now our task is to merge current with previous already merged intervals. So we have to check whether 7, 9 is overlapping with any of the previous intervals or not. So that value is actually held by start and end. So here if we see, current dot start is this value and current dot end is this value. So here you can see current dot start is 7 and value of end is 6. So it means current dot start is not less than or equal to end, because value of end is 6 and current dot start is 7. So here you can see there is a gap between these two intervals. Therefore they are not overlapping with each other. So this condition comes out to be false. So the else part will be executed. And in the else part, as we have already found one gap in between these two intervals and this interval, we can now safely merge these two intervals, because when we go ahead, these two intervals will not be get affected and we can simply merge them and add it to the result. So in the result we are adding new interval start, end. So we are creating a new interval of start and end which is 1, 6 and we are adding it to result. So it would look something like this, that it is merged like this and it is added to result list. Moving ahead. So once we have merged these two intervals and there is a gap between the current and this merged interval, now our task will be to focus from 7, 9 to rest of the elements ahead. We have to forget this merging now, because we have already merged these two intervals and there are no more intervals which can get merged to these two intervals. So therefore we have to forget this part now. And as we have started with 1, 3 at the start, because that was the first interval, now we have to start from 7, 9 thinking it is the first interval. So therefore now start will become current start. We will assign the value of current dot start which is 7 to start. And end will become current dot end which will become 9. So this is now our fresh interval, and if there are more intervals after 7, 9, this 7, 9 will be compared with these intervals, and these intervals are already merged and they are added to the result list, so we don't touch them now. Moving ahead, we will increment I. So I will become 3 and I is not less than 3. Therefore this condition comes out to be false. And for loop will terminate because there are no more elements left to be compared with this 7, 9. So this for loop will terminate. And one thing to notice, as soon as this for loop will terminate, whatever the value start and end will hold, that will hold an actual interval which also needs to be added to the result. So here you can see 7, 9 was the single most interval left, and there are no more intervals left which can be merged with 7, 9. So this 7, 9 also needs to be added to the result list. So at the end we have to add this 7, 9 also to our result list, because this is a non-overlapping interval. So we do result.add new interval and we pass the value of start and end which is 7, 9. So it would look something like this, that this is also one such non-overlapping interval. And our task was to merge all the overlapping intervals and only return the non-overlapping intervals. So 1, 3 and 2, 6 got merged to 1, 6 and 7, 9 didn't get merged with any of the intervals, so it came out as 7, 9. So these two are our answers, 1, 6 and 7, 9. So at the end, we will simply return the list of interval which is our result list. So friend, this was all about the problem how to merge an overlapping intervals and return back all the non-overlapping intervals. So in this video we will actually see one more problem, insert interval. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So in this problem, we are given with a list of non-overlapping intervals which are sorted by their start time. We are also given with a interval which we need to insert into the list at a valid position in such a way that if that interval overlaps with any of the intervals which are given in the list, then we have to merge all those intervals and return back a list of mutually exclusive intervals, which means we need to return back a list of intervals which are different and non-overlapping. So let's see an example. Let's say we are given with this list of intervals 1, 3, 5, 7, 8, 10. Now they are non-overlapping and sorted by their start time. And let's say we are given with this new interval 4, 9. Our task is to insert this 4, 9 into this list in such a way that if this new interval overlaps with any of the interval given in this list, we have to merge it with new interval and return back a list of mutually exclusive intervals. So the output is 1, 3 and 4, 10. Now how this output came, let's see via diagram. So this is our time axis, and if we plot all these intervals on this time axis, it would look something like this: 1, 3, 5, 7, 8, 10. We have to insert 4, 9. So it will go from 4 to 9. So here you can see this 4, 9 doesn't overlap with 1, 3. So 1, 3 doesn't get affected by insertion of 4, 9 because they are not overlapping. So 1, 3 will be part of our answer because it's mutually exclusive. So this is the first part. Now here you can see when we will insert 4, 9, it will affect 5, 7 and also 8, 10. So as 4, 9 is completely overlapping 5, 7, if we put 5, 7 on top of 4, 9, that means merging of these two intervals will not get affected because 4, 9 is already overlapping completely 5, 7. But in this case, 4, 9 is ending at 9 and 8, 10 is ending at 10. So if we put 8, 10 on top of 4, 9, the region will get expanded till 10. And as 4 is less than 8, so start will remain the same, but end will change because 4, 9 is overlapping with 8, 10. And when we merge these two intervals, we take the end time of both the intervals and we see which is the maximum. So here 10 is the maximum. So the merge interval will be something like this. It would be 4, 10. So the next output is 4, 10. Now let's move ahead and see some of the concepts behind this insertion and merging. Let's say we are given with these two intervals. We need to insert A. So A and B are non-overlapping. So it means we can simply insert A without touching B. So we simply insert A. Now let's say A and B are overlapping. So when we will merge these two intervals, their area will be from here to here. So this is the start of A and this is the end of B. So if we take this interval as C, then we have to keep a formula as C. Start time will become the minimum of A dot start and B dot start, and the end time will become the max of A dot end and B dot end. So this condition comes into picture if they are overlapping. So here you can see, let's say if we give it a value as 1, 4, 3, 6. So we know that when we will merge these two intervals, the minimum of 3 and 1, so C will become 1 and maximum of 4 and 6 will be 6. We know that the area of this merging will be 1, 6 because we have to accommodate both the intervals. So this formula comes handy. Minimum of A dot start and B dot start. A dot start is 1, B dot start is 3. So minimum is 1 and C's end will become max of A dot end and B dot end. A dot end is 4, B dot end is 6. So C's end will become 6. So this interval will expand from 1 to 6. So C becomes A dot start, which is this, and B dot end, which is this. Similarly, here A completely overlaps B. So if we apply this formula, the C will become A dot start because A dot start is coming before B dot start, and C dot end will become A dot end because it is coming after B dot end. We have to take the max value. And if this is the scenario, then by applying this formula, C start will become B start and C's end will become A's end. So this would be the area of the C interval. And if B completely overlaps A, and if we want to insert A, so by applying this formula, C start will become B start and C end will become B's end. So this is how we actually insert and merge the intervals together. Now let's see via an example. If we have these 4 intervals which are non-overlapping, sorted by their start time, and we have to insert a new interval 4, 9. So if we plot all these intervals on the time axis, it would look something like this: 1, 3, 5, 7, 8, 10, 11, 12. Our task is to insert 4, 9. So here, as we want to insert this new interval from 4 to 9, there will be 3 regions around this 4, 9 which will get affected when we will insert this new interval. So one region is just before 4, which is this. Another region is this, between 4 to 9, and the third region is just after 9. So here we are taking the region 1 as just before 4, not even equal to 4, and here just after 9, not even equal to 9, because if any of the interval touches this boundary like this, then they also need to be merged because they are overlapping with each other. And so we need to keep this condition in mind, that in region 1 we have to simply check for less than intervals. In region 3 it should be greater than the end time, and in this region if they overlap we have to directly merge them. So how we can solve this type of problem is, we have to take these 3 regions. First we have to take all the intervals which are part of region 1, and all the intervals which are part of region 1 will satisfy this condition, that their end time, let's say this part, is less than the new interval start time. It means they are not overlapping, there is a gap. So this less than condition is helpful. If they become equal, then they actually overlap and we have to merge them. So first we cater for less than condition and we figure out what are all the intervals which are not touching 4, 9. So those intervals we directly take into our result list because they are not touching 4, 9 and they are not overlapping 4, 9. So let's say if there are n number of intervals before 4, so we have to check each interval's end time and check whether it is less than the new interval start time. If it is less than the new interval start time, we know that they belong to this region. So after placing all the elements of region 1, we come to region 2. Now here what we check is, let's say if we take this example. So here if this interval has to belong in region 2, what we do is we take its start time and we check whether it is less than or equal to the new interval's end time. Now here we are checking for this condition, less than or equal to. So let's say phi is less than 9. So it means this interval belongs to region 2 because we have already excluded the region 1 intervals. And if any of the intervals is left, if this condition satisfies that phi is less than 9 or equal to 9, then this region, even if it expands beyond 4, 9, it will still overlap with 4, 9. And why we are taking this equal condition is because, let's say instead of 8, 10 we have 9, 12. So 9 is the start time, and if 9 is equal to new interval's end time, so still it is overlapping with this interval and we have to merge them. So it still belongs to region 2. So this is the main condition. For region 1, all the intervals end time should be less than new interval start time. So they will completely belong into this area and they will be non-overlapping. In this region they will overlap. So we have to simply check the interval start time and we have to check it is less than equal to the new interval's end time. If that is the condition, they still overlap and we have to merge them. So here if you see 4, 9 overlaps 8, 10 because 8 is the start time and it lies before 9 because 8 is less than equal to 9. So therefore when we will insert this interval, it will affect 5, 7 and 8, 10, and we know the formula that how to merge the two intervals together, which we saw in our previous slide. So after we add all these elements into the list, whatever elements are remaining, these are out of the boundaries of this 4, 9, which is the new interval which we want to insert. So we can directly add them into the list. They won't get affected by the insertion of this new interval. So after merging 5, 7 with 4, 9 and 8, 10 with 4, 9, it will become something like this. So our overall answer becomes 1, 3, 4, 10 and 11, 12. So the algorithm is something like this. We have to skip and add intervals that come before the new interval to the result list. So all the intervals of region 1 which are coming just before the new interval, we have to simply add onto the list. We have to merge all the intervals that overlap with the new interval. So this interval and this interval, they are overlapping with this new interval. So we have to merge it with this new interval. We have to add that merged interval into the result. So this is the interval which gets merged. We add this into the result. And finally we insert the remaining intervals to the result. So these are the remaining intervals. There can be many intervals like this. We have to just insert them to the result because they are non-overlapping and mutually exclusive. So this region covers this part. This region covers the overlapping part, and this region covers all the remaining elements. So all these regions will be captured by a simple while loop in the algorithm. So let's move ahead and see the algorithm. So this is the algorithm. So this while loop is for the region 1 where we simply skip the elements which just come before the new interval. This while loop is covering the intervals which are getting overlapped with the new interval, and this while loop is just adding the remaining intervals. So let's see the demonstration of this algorithm step by step. We'll call the insert method. We'll pass the list of intervals and a new interval which we want to insert, which is 2, 6. So let's say we have list of interval as 0, 1, 3, 5, 6, 7, 9, 10, and we need to insert 2, 6. So if we plot all these intervals on the time axis, it would look something like this: 0, 1, 3, 5, 6, 7, 9, 10. We need to insert 2, 6, which is from time 2 to 6. Moving ahead. So here we are just simply checking for the base cases, that if list is null or empty, we simply return the list. So currently list is not empty and it is not equal to null. So for the new interval you can think that it's a valid interval. As we have to return the list of mutually exclusive intervals, we will create a result list which is currently empty. Now as we need to traverse each and every element of this intervals list, we'll create an integer I starting from 0 index. So first we are picking 0, 1. Now in this while loop we are checking that whether 0, 1, when this 2, 6 will be inserted into the list of intervals, will this get affected or not. So first we check whether I is less than intervals.size. We are simply checking whether value of I is less than interval.size, which is 4. Because as we are traversing each interval one by one, there would be a time that I will completely traverse all the elements. So we need to break from the while loop at that moment. So currently I is less than intervals.size. The other condition we check is we get this interval. So we do intervals.get I. So we get 0, 1. And as we discussed, we will check its end time with the new interval start time. And we check whether this interval's end time is less than new interval start time, because if it is less than new interval start time, it means they are not overlapping. There is a gap between. So intervals.get I is this interval. If we do dot end, we get 1. We check whether 1 is less than new intervals.start. So new interval.start is 2. So 1 is less than 2. So it means this condition comes out to be true, which signifies that 0, 1 doesn't overlap with 2, 6. and we can simply skip this element and add it to the result list because this won't get affected by insertion of this new interval. So 0, becomes part of the result. Now we will increment I. I will come to the index 1. So I is less than intervals.size, which is 4. Intervals.get I, which is 1, which is 3, 5. Now we are at 3, 5. We check whether this interval's end is less than new intervals.start. So here this interval dot end, which is 5. We check whether it is less than new intervals.start, which is 2. So this condition comes out to be false, which suggests that all the intervals which were just coming before new interval have already been part of the result, and once we reach on this interval, this condition comes out to be false, which actually states that 3, 5 will either lie in the area of new interval or beyond that, but it won't lie here in the region 1 because this condition came out to be false. So ideally this while loop will terminate, which signifies that all the intervals which were coming before new interval have been added to the result list, and we can move ahead with the another while loop. I is less than intervals.size. Now here we actually check for the second region, that whether 3, 5 is overlapping with 2, 6 or not. And we already discussed how we can do that is intervals.get I, which is this interval. We simply check its start time, which is 3. We check whether it is less than or equal to new intervals.end. So 3 is less than equal to new intervals.end, which is 6. So which is true. So it means these two intervals are overlapping, which is being proved by this condition. And so the condition in while loop comes out to be true. So first we will get this interval 3, 5. We assign it to current like this. Moving ahead. Now as we need to merge 2, 6 with 3, 5. So we know the formula that if we merge two intervals, let's say A and B, and let's say result interval is C, so it becomes C start becomes min of A dot start, B dot start, and C's end will become max of A dot end and B dot end. So here these two are the same conditions, and here C is our new interval only. We are simply merging 3, 5 into the new interval only. So new interval start will become the minimum of current start, which is this, and new interval start, which is 2. So minimum of 3, 2 will give 2. So new interval dot start will become 2, which is already 2. So this won't get changed. Now new interval end will become max of A dot end and B dot end. So current dot end and new interval dot end, we take max of it. So current dot end is 5 and new interval's end is 6. So if we take max of it, we get 6, which is assigned to new intervals dot end. So new interval's end doesn't get changed because it is already 6. So it means we have merged these two intervals and the resulting interval is same, 2, 6. Because this new interval completely overlapped the current interval. Moving ahead. Now we are done with this interval also. So we'll increment I. I reaches to 6, 7. So here I is less than intervals.size. Now here if we do intervals.get I, we get 6, 7. So friends, here you can see that why this less than equal to is important. This 6, 7 is starting where this new interval is ending. So it means they are still overlapping because the interval start, which is 6, is actually equal to new interval's end, which is also 6. So therefore they are overlapping and we have to merge these two intervals as well. We can't exclude 6, 7 because it is just overlapping with 2, 6. So this condition is important. So the overall condition in while loop comes out to be true. we do intervals.getI. The interval 6, 7 will be assigned to current like this. And we have to merge these two intervals now. So we'll use the same formula. The new interval.start will become the minimum of current.start, which is 6, and new interval.start, which is 2. So minimum will give 2. So new interval.start will become 2, which is already at 2. Now new interval's end will become the max of current.end and new interval.end. So max of current.end, which is 7, and new interval.end, which is 6. So it will give 7. So here is the one critical step, that new interval.end will become 7 now, because after merging these two elements, the new interval will expand to 7 like this, that we have merged these two intervals. Moving ahead, we will increment I. I becomes 9, 10. I is still less than intervals.size, because value of I is, this is 0, 1, 2, 3. 3 is less than 4. Intervals.getI, which is 3, will give 9, 10. And here you can see this 9, 10 is actually belonging to the third region. So therefore its start, if we compare it with new intervals.end, so 9 is less than equal to new intervals.end, which is 7. So this condition comes out to be false. It means 9, 10 is the remaining element and it doesn't overlaps with 2, 7. So we can directly add this 9, 10 and all the elements after that via this while loop. So this condition comes out to be false. So here you can see that before adding 9, 10 into the result list, we have to also insert 2, 7, which is our merged interval, into the result, which is actually merging 2, 6, which was our new interval, with 3, 5 and 6, 7. So after this 3 intervals merge, we get 2, 7. So this is one important step. We have to add this new interval into the result. So it will become like this. And now using this while loop, we will add the remaining interval into the result. So I is still less than intervals.size. And as this condition reached this while loop, we are sure that all the remaining elements will be non-overlapping with this new interval. So we can directly add 9, 10 to the result. We do result.add and we pass in intervals.getI, which is 9, 10. So it looks something like this. And then we increment I. So I goes beyond the boundaries of this interval list. And now this while loop condition comes out to be false, because value of I is 4 and intervals.size is also 4. 4 is not less than 4. So this condition comes out to be false. And at the end we simply return the result, which is 0, 1, 2, 7 and 9, 10. 0, 1 doesn't overlap with this new interval and 9, 10 also doesn't overlap with this new interval. 3, 5 and 6, 7 were merged with 2, 6 and became 2, 7. So this was the answer. So friend, this was all about the algorithm. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.